Okay, we use the same procedure for the NTA name to add the table, summary table to the layer. So next, it will be use the tabulate intersection tool. So yeah, we will save the changes and we will go to the next one, the last one for geoprocessing. So we did intersect and union tools to create new feature classes with combined features and data. With these tools, the data, for example, number of housing units or population is not apportioned, split into parts and allocated to the new features. For example, if a single neighborhood crosses more than one land use zone or more than one fire company, the neighborhood housing data should be split between polygons. So we will use the tabulate intersection tool to estimate the number of disabled persons in fire company boundaries using census tracts and fire company polygons. By default, this tool makes apportionments proportional to the areas of split parts of polygons, such as block groups, assuming that the populations of interest are uniformly distributed by area with polygons. And here we will do is the map contains Manhattan census tracts classified with the number of disabled persons, all disabilities, and Manhattan fire companies. We will zoom in and turn the Manhattan fire companies layer on and off to see tracts compared to the borders of fire companies. So Manhattan fire companies, we will turn it on and off. So now we can see tracts and a fire company clearly do not share exact borders as seen in this graph. And we study the tracts and the fire company polygons. So we will use small study area composed of 4 fire companies and 20 census tracts in the Upper West Side to better see the working of the tabulate intersection tool. We will close the disabled person fire company study Manhattan map and open the disabled person fire company study Upper West Side. It's right here. Map, and the map label include fire companies 22 and 25. Ladder 74 and 76 engine tracts are labeled with tracts ID, white halo, and the number of disabled persons per tract yellow halo. And we will zoom to fire company 76, which is right here, and 5 tracts selected in the figure intersect this fire company polygon, and 2 tracts 019300 and 018900 are completely within the polygon, and their populations will be entirely in the fire company. 2 tracts 019500 and 019100 are within the polygon, but extend into the river, and 018700 is split between fire companies 76 and 22. That tract's disabled person population 880 should be split approximately 50-50 with 440 persons residing in fire company 76 and 440 persons residing in fire company 22. And study additional tracts in the other fire company polygons. I identify tracts that are split between the fire company polygons. And we will use the tabular intersection to apportion the population of disabled persons to the fire company. So on the Analysis tab, we will click the Tool button, and in the Geoprocessing pane, we will search for and open the Tabulate intersection tool. Tabulate intersection tool. Tabulate intersection. It's right here. Tabulate intersection tool. And type, or we can make selection and save our output into the geodatabase chapter 6. So the first one we will put Upper West Side Fire Company, and zone fields fire code number, and input class features Upper West Side tracts, and output feature let me put into geodatabase chapter 6, and name we will name it disabled persons per fire company, and click save. And fields, it will be tract ID, and some fields will be disability, XY tolerance -1 feet, and output units unknown. And we will run the tool and close it after it finishes. Disregard any warning about the tolerance settings, so that's fine. Completed with warnings, that's fine. Okay, and then open the disabled person fire company table, and for field tracts ID, and we will choose disable. Okay, I'm going to, whoopsie, that's fine. Disability, we will do ascending, and we will scroll to select tracts, 10700, 1018700, and those are right here. Okay, 1, and let me hit Control 2. Okay, these 2, and then the population of disabled persons in the tract is indeed split 50-50 between fire companies 22 and 76, with each 236 persons. Note that since the tracts 10193 right here, okay, this one, completely within fire company 76 has a total population of 1,620 disabled person. And we will use summary statistic for the following settings to calculate the total number of disabled person in each fire company and save the project. And now what we're gonna do is go back to tools and summary statistics. Summary statistics, and then input table that I will use is disabled person fire company, and output table disabled person fire company. I can, okay, that's fine. I will say total T, okay. And field, it will be the disability, how many people are there, and sum, and file code number. Okay, click run. And now this is the total number. Let's see. Okay, so fire 22, we have 236, and then the other one we have 1,800, and 556. Alright, so the whole chapter we did was right here, geoprocessing. And next we're going to move is for digitizing. So geoprocessing, digitizing, and we will do geocoding. That's for working with spatial data. And select by attribute for feature extraction. We did for the tracts. We start with the tracts, and that tracts for one county in Hennepin County, Minnesota, and we did select by attributes, select by location, select by attributes, and you can do SQL there, and geoprocessing tools. That the scenario was Hennepin County census tracts for one city of Minneapolis only, but cannot use select by attributes, not attributes for Minneapolis. And U.S. county subdivision. So Minneapolis is a municipality with Hennepin County, and select Minneapolis, and then we can do select by location, points near polygons, and that points near points, and feature select feature data that we can select some subset. For example, we just want this district's school, or maybe some hospitals just on upper west side of Manhattan. And highway select for construction and neighborhoods affected, and lines intersecting polygons. So line intersecting polygons, flood zones, and streets or sidewalks affected by floods. More geoprocessing tools that we did was clip, used as a cookie cutter. We cut it. And clip problems. There are some problems that might be there. Building can cross boundaries, and clipping can misleading. For example, FEMA flood zones and buildings, streets can cross boundaries, and clipping can cause geocoding issues. Streets and neighborhood, though we have to solve it. So dissolve, we did use the dissolve tool for some waterways and some blocks in Manhattan, New York. So these common fields value to remove interior lines with each polygon, forming new polygons, aggregates sums data while dissolving, and dissolve results that you get a big boundary and a lot of fields that are combined. Append that, for example, I want to add another county, then you add them together. So it's kind of like adding more rows. Adds one or more data sets into an existing data sets. Feature must be of same type and have identical attributes. So identical attributes is very important, and the feature must have the same type. Means the columns are all the same. So put data sets may overlap one another and or the target data sets. And merge, it's kind of like combine multiple inputs data of the same data type into a single new output data set. So merge is more like you combine into everything, the whole. So it's kind of like you still adding the rows together. So intersect computes a geometric intersection of features or portions of features with overlap in all layers, and or feature classes will be written to the output feature class. Inputs can have a different geometry types. So for example, that's the one we did for the New York exercises, and intersect tables, Manhattan streets, fire companies that we just did. And intersect results that we can see that it would give you extra information that you add there. So summarize street length for fire companies that we did. Union overlay two polygon layers, resulting output layer has combined attribute data of two inputs. Contains all the polygon from the inputs whether or not they overlay. So the union kind of just like we add more rows together and everything will be combined together. So attribute table, for example, that neighborhood and everything, and we summarize everything, and we can use the same field and put them together. But here we just summarize everything and we kind of combine them and union